You ready? Okay. I'm going to get started on my talk on Plone and the real-time web. I'm David Glick. I've been involved in Plone for about 15 years. First working with Classic UI and more recently with Volto, although I'm the backend guy, one of the backend guys at Kit Concept, so I am sometimes doing Volto and a lot of times doing backend things. So this talk is about the real-time web. What is the real-time web? It's anything where you're seeing information as soon as it's published. So if you're thinking about cases where the server is pushing data to you as it's available rather than the client requesting data at a random time. So we're talking about things like live data, stock quotes, sports scores, things like that. We're talking about feeds, like Mastodon or Threads or Blue Sky. I'm not going to mention that other one. We're talking about collaborative editing sorts of things. Think Google Docs or Figma, that sort of thing. I want to get started with my live demo, and we'll see if this works. So take your device and go to this site. I'll give you a little bit to get that pulled up. And if all goes well, you'll see a map. And if you have location sharing turned on your phone, you'll be able to share your location on the map and type in your name. I'll pull it up here on the screen in a second once I see fewer people clicking. Is it working? Yeah, I'll give it a minute. You got an error. I knew that might happen because it happened to Fred yesterday. I don't know why. It's a demo. Let's see. How do I... What's that? In Chrome it works. Okay, there we got some people. Well, that's interesting. Why is everybody up there? I guess we see where I'm located and then where the... Well, why am I down there actually is the question. Well, that's interesting. Take my point off of there. Okay, we shouldn't spend any more time on the demo. Anyway, the point is, this is Plone. This is a block I made called the live map block. When you load the block, it's connecting over a WebSocket to a server that is running both Plone and a little app that's handling the WebSockets. And then as people join, it shares the location. This is also the first time I've tried this demo with this many people connecting to it, so I thought there might be some issues. Okay, this is the demo in case that didn't work at all. So let's talk about how this works. So I mentioned WebSockets. So first we should talk about HTTP in general. HTTP is, the client makes a request, it gets a response back. Pretty basic stuff. WebSockets are another layer that's implemented on top of HTTP that provides real-time communication. So there's an initial handshake, which looks similar to an HTTP request and response. The client says, hey, I want to get this path, but I want to use WebSockets. The server says, yeah, sure, I support WebSockets. And then everything after that can be either one sending data in real time as needed. Just to show in a little bit more detail, this is what that handshake looks like. It's similar to a normal HTTP request, but it says I want to upgrade to a WebSocket. And then the response says switching protocols. Okay, so you need a server that can handle WebSockets. And generally think about what sorts of things you're using this for. It's cases where you want to distribute a message, right, from somebody who's publishing it to somebody who's receiving it, or from multiple people who are publishing it to multiple receivers. So there's a common pattern that's involved here called the pub sub pattern, where you have any number of publishers that are sending messages. Those messages might be tagged with specific channels that they're relevant to. And then you have a bunch of subscribers that can say, hey, I want to listen to the messages on this channel. And then they receive them. And then in the middle, you have this thing that's called the message broker or the event bus, which is taking care of getting the messages to the right place. And in a simple system, the message broker could just be a single process that's keeping track of what's connected to it and relaying the messages there. In a more scaled up system, you might have a whole bunch of backends handling a bunch of load. And so you need to take the messages that are coming in on one backend and relay them to all the other backends. So in that case, the message broker might be a separate piece of software like Redis or Apache Kafka or Postgres, different things. For my demo, I just did a really simple thing in a single Python process. And then we should talk a little bit about concurrency, right? Because we have a whole bunch of connections that we're handling at the same time. Everybody who's connected to the map, who's connected to the thing that you're using with WebSockets. There's different ways that you can handle concurrency in Python. And one of the models is threads. So you have a server that's running multiple threads. Each thread has its own piece of a program that it's running in sequence. And then the operating system takes care of letting the threads take turns using the CPU. And the order can kind of be a little bit non-deterministic, just whichever thread gets scheduled next by the operating system. A different way of handling concurrency is with routines, or called cooperative multitasking. If you've used asyncio in Python, that's an example of this approach. So here you have a single thread that's handling tasks in sequence from a number of different things that need to run, and each task is called a coroutine, and each coroutine does some work and then yields or waits. So it says basically, I'm done processing for now. Come back to me when you have a chance, and then it goes on to the next one. So it's a little bit more organized way of doing multitasking, but only runs on one CPU, unless you scale up into multiple CPUs in a different way. Okay, why am I spending time on this? You don't need to know the details, but the important thing to know is Plone has always used a multi-threaded model. We have requests coming in. Each request gets sent to one particular thread. Python. So HTTP has been around since 1991-ish. That was simple request response model. Ever since it existed, people were trying to figure out how can we do something that's more real time. So we had long polling as a pattern, which was sort of it's just HTTP, but you make a request and then you hold it open and the server can send something back when it's ready to, right? So that gives the server a little bit of control over when it sends data. In 2002, we had the twisted library in Python, which is a library that handles a lot of concurrent networking sorts of things within Python. If you're interested in these topics, it's good to know something about it. In 2006, that was when Writely was created, which became Google Docs. So the idea of collaborative editing within your browser and sort of real-time seeing what other users are doing. That was not using WebSockets, but it sort of was exploring different ways to do that. In 2010, we got WebSockets in Chrome, and then the next year, there was a standard which quickly got implemented in different browsers. So now it became possible to do this in a standardized way. Python got support for async processing with asyncio. I mean, there were different ways to do async processing, but this is the commonly used one these days, and it came around in 2014 with Python 3.4. Once we had asyncio, people started to figure out how to build web frameworks using it. So ASGI is the asynchronous server gateway interface, and it's basically creating a standard way for taking HTTP connections and connecting them to some processing that's happening in asyncio. So before this, we had WSGI, which was a standard interface for doing that with non-async IO request handling. And ASGI was sort of modifying that to work with async Python. So that was like the basic standard. Then we had different web frameworks that were figuring out how to build things on top of that. Django channels was sort of a fairly early experiment with doing async IO and handling WebSockets in Django. It sort of figured out some of the patterns, which then were also adapted by frameworks like Starlet and FastAPI, which is built on top of Starlet. And that's sort of, 2018 is when those frameworks got started, so it's already 5 or 6 years ago. But that kind of brings us into the modern era where we have frameworks in Python that support this stuff. They just aren't Plone. Okay, so what about what's been happening in Plone in the meantime? Like, it'd be nice to have some real-time processing in Plone, right? So there's a couple big challenges for doing this sort of stuff in Plone, and one is the server that Plone runs on. So for a long time, that was the Z server, which was built into Zope. And like I said, it's a threaded model, and the Z server supported multiple protocols, right? It supported HTTP, but it also supported WebDave, and I think it had a SMTP interface, FTP. So it wasn't outside the realm of possibility that somebody could have built support for WebSockets on it, but as far as I know, nobody has tried to do that, except for OSCO. I'll come to that in a second. But yeah, the point is we just didn't really have the foundation that we needed to do WebSocket processing in Plone for many years. More recently, Plone uses Zope has become a WSGI application, which means it is now embedded in WSGI servers in sort of the standard way. That makes it a little bit easier to approach, and I'll show how I did that later. But it's still not really built in. The other big challenge with Plone and WebSockets is the ZODB cache. So when you're dealing with a bunch of WebSocket connections, you have a lot of different visitors with an open connection to your web server. And with the ZODB, the way that it performs well is you have a big cache of objects that you've loaded, and you have to populate that cache over the course of a request as it's populating, and each request that's running in a thread has its own ZODB cache. What this means is we typically in Plone try to limit it to a fairly small number of threads that are processing requests in parallel, because we don't want to use all of the RAM that the server has. We need to sort of, each ZODB cache uses a lot of RAM, and we need to limit how much we use. But despite these challenges, people have tried to do real-time stuff in Plone. In 2012 and 2013, there was a project that JC Brand was driving forward called collective.xmpp.chat and some other things. And this was sort of bypassing those challenges by running a separate server that handled the WebSockets, and that was an XMPP server with implemented in, I forget the language now, Erlang or something like that. So you had to run that separately alongside Plone. Jump forward to 2017, we had Guillotina, which was the effort to rewrite the back end of Plone, or at least the framework pieces of it. It sort of turned it into its own project that has gone in slightly different directions than Plone. But it had support for WebSockets and was implemented in async Python from the start. So that was one way that our community has experimented with this. And then I mentioned Asko Suka. In 2018 and 2019, he was doing some experiments. He posted about using Plone with a RabbitMQ server that was handling some WebSockets. And then he sort of built his own Frankenstein Z server that was working with Twisted and handling WebSockets that way. None of these things really became mainstream. They were demonstrations of how this could work, but not all the pieces got released, or people figured out things that were challenging to make work well. They never really got to the production stage of things, I would say. I think that we now have the pieces to do a little bit better. We've got WSGI by default in Plone in Zope. That's how it's served. That means we can sort of take our pick of the different Python web servers that are available and use the one that works best for us. We've got ASGI Python web frameworks that support WebSockets, support async IO, Starlet, for example. We've got servers that handle the ASGI specification. Uvicorn is one of them. And then we've got middleware that you can use in your ASGI server to run a WSGI app. So it'll say, whatever async things are happening over here, I'm going to create a pool of threads over here, and the WSGI app can do its processing in those threads. So the basic idea of how I've implemented this demo with the map is you get routed to different places based on which path you visit. If you go to /ws something, you end up in a Starlet application that's handling WebSockets. And if you go anywhere else, you just get sent through to Plone. But all this routing is and processing is happening in a single Python process. I'm going to show some code. I don't know how readable it is on the screen here. Don't worry too much about the details. I'll talk it through a little bit. This is the main entry point to the application. So you can see down at the bottom, we're running Uvicorn and we're telling it, here's our app, serve it at this address. The app here is an instance of Starlet, and we've basically given it some routes where you can see here /ws/livemap is going to go to the livemap app, and / is going to go to Zope. Okay, so that's how we handle the routing. How did we get those things? Zope, we're just calling make WSGI app, which is this normal function from Zope. It's the same way that Zope gets set up in a standard installation with Waitress or something like that. So we're loading Zope with its specified configuration. We're then wrapping it in this WSGI middleware, which is basically telling it how many threads we want to run it with. And then that's what we pass to Starlet. So that gives us our thread pool for Zope. And then meanwhile, I have the app that's handling the map, which I've imported separately. I'll show you that in a second. And that we're passing it a reference to the thread pool so that it can run some processes in Plone if it wants to, but that's not the main thing that we're doing here. Okay, so what does this little WebSocket app look like? We've got an async function here, stream. So when somebody connects to /ws/livemap/stream, that will get handled by this code. It gets past a WebSocket object, which comes from Starlet. And we're grabbing some query parameters that got sent. So what's the block ID that this map was in on the front end? What's the unique identifier of the client that's connecting? This is a function I'm calling to handle authentication using the auth token that's in the request headers. And then I'm basically creating this visitor object and adding it to a channel, which is just a dictionary. It's keeping track of who's connected right now. And then I'm sending the person who just connected a list of everybody who's already here. So I just loop through the existing list of visitors and send some JSON to the WebSocket. And then I am awaiting channel.follow, which is basically going to receive any new updates for this particular connection of messages that they're sending, which is, the new location, the new name to go on the map. And that will just run indefinitely. And then we can do some error handling. That last piece of listening for the messages that are coming in looks like this. So it's just an endless loop. We await for the next message that's been sent. So that can take however long it takes. Other processing is happening in the background. And then we take the location and name, update our visitor, and send it to all of the other people who are currently connected. So not a lot of complication to what's happening in the back end. And also, obviously, not a lot of Plone specific stuff here. So I have the asgi.py, the entry point that I showed you. How do we actually start things up with that? I just made a small change in my make file. So when I run make backend start, it runs this. It's running Python with the live map.asgi module. So that's that entry point that will run uvicorn. And then I pass it the path to my SOAP configuration, and that gets it going. And then the other piece of this is picture the whole path of how a request is coming in. It's coming to some front-end web server, and then that's sending things on to Volto or to the backend. And I had to add some special handling of the /ws route to basically send the WebSockets directly through to the backend. So this is configuration for traffic. It's basically saying, if we get a request for my domain and on this path, then we'll send it to the web service backend. So it's not going through Volto, it's not going through Varnish or a cache server or anything like that. Yeah, I didn't show this in the demo, but one of the things I'd made it was I wanted to not just have a separate WebSocket application, but actually have some interaction between that application and Plone. So there's two features I implemented. One is if you go to the map and you type in your name and you're logged in, it will actually update your Plone user profile. It'll change your name there. So it's actually doing a write into the ZODB. And the other feature I added is if you go to your profile and you change your name there and you've got the map open in another tab, it'll update right away and show that your new name there. There's some sort of esoteric low-level things that I'm running in asyncio to do this. Basically, the first one here is I've got code that's running in the thread pool. So this is like normal Plone code, such as the event handler when you change your name in the profile. And so this is getting the asyncio event loop. It's telling it to run something. Oh, no, sorry, this is the other one. This is we've got something that's in a WebSocket and we run some normal Plone code. So we tell it to run in the thread executor from Plone. And then this other one is what I was saying before. This is if you've got normal Plone code that wants to send something over a WebSocket, then we have to tell asyncio to run a coroutine from this function in the current event loop. So there's ways to make this work. It's not necessarily super clear, but it's a building block. Okay, so I had this neat demo. I talked about the other efforts to use WebSockets in Plone that sort of didn't reach a production readiness state. So let's talk a little bit about where we are. I sort of see this effort like this. We've got figuring out the primitives, like what are the pieces to make this thing work. That's what I've been doing here in this talk, just doing some experiments and trying to hack something together. If we want to actually build production websites with this, we need frameworks, right? We need to figure out what are the patterns. what are the approaches that we want to document, so that we're all moving in the same direction, so that if there's a site that has 5 different blocks that are all using WebSockets, they're all doing that in the same way and not competing with each other somehow. And then once we have those patterns figured out, then we can build different solutions on top of that. And we could imagine a future where Plone has WebSocket support turned on by default, and you can write an add-on for Plone that just assumes that's available and uses it in cases where it makes sense for the user experience. I have some ideas of use cases. I don't know that mine are the best ones that we should do or the only ones that we should do, just to sort of get people's minds thinking. One idea would be microblogging. So, Moritz is at a Plone conf, he's typing away, taking notes. Imagine if every time he started a new block and hit enter, that was immediately visible to somebody who was watching the talk remotely. So they're getting sort of a live stream of updates. You see this sort of interface in news websites, sometimes around major events where they're trying to provide live coverage of updates as they're happening. We could have some editor-focused features like notifications. If you're on a page and somebody else edits it or edits something else in the same section, maybe we could pop up a toast to show you that right away, just so you aren't accidentally overwriting somebody's work or hitting a lock at some point. If you're doing something that's going to run for a long time, like say moving a folder with 1,000 items somewhere else, we need to work on the performance of that. That's a different issue, but anything where it's going to take a while, we could have the process that's running send updates over a WebSocket, and the front end could be sort of showing your status in real time. And then one that is sort of something I personally would like is if I'm editing in a Plone site and collaborating with other editors. I'm not talking about real-time collaboration like Google Docs, but I'm thinking of like the commenting feature in Google Docs or in Figma, where you can sort of select something and leave a note, and then people can reply to that in a thread and have a discussion like right in the website about changes that need to happen. Could be cool. Yeah, so there's figuring out what use cases we want to build and how to make that happen is one of the next things. And then also just making this thing production ready. There's various missing pieces that I've sort of glossed over. So how do we handle authentication for the requests that come in over the WebSocket? Do we do that the same as in Plone or differently? What sort of conventions do we want to have around channels and how we name them so that anybody knows, oh, I can subscribe to, content : a UID, and then any messages relevant to that content item would be sent there, for example. Maybe we need to support WebSockets in the Volto dev proxy, so you don't have to connect to a different place when you're doing local development versus serving something in production. I mentioned, when you're thinking about scaling up, you maybe have multiple instances, and that makes it more difficult to pass the messages between all of them. So figuring out how to make this sort of thing work with a broker of some sort, or perhaps support different ones like Redis, Postgres, etc. And then just all the considerations around how do we make this thing robust. If somebody is on the web page and loses the connection, maybe it still looks like they're connected, but they aren't actually receiving any data anymore. Can we detect that and reconnect? Can we make the thing secure by validating that you're only receiving incoming connections from your own website and not from people who are trying to hack you from somewhere else? How do we do monitoring for this to make sure that the server load is what it should be? So there's potentially a lot of work to do. And I just wanted to give this talk as sort of starting a conversation and hopefully giving an invitation to anybody who's interested to take on these sorts of problems and work on them. I don't think that they're intractable or impossible to solve, even though they aren't things that we've typically done in Plone before. I'm not necessarily personally planning to tackle any of these things immediately. Although if somebody is interested in paying me or Kit Concept to do that, we could certainly talk about it, or I could just give advice on a project that you're taking on along these lines. But yeah, I think there's a lot of potential. And finally, this is the URL for the repository for the demo that I showed, and it has all of the code both for the front end and back end if you want to look at some of the details I didn't show here. It's a typical cookie Plone project, so it has both the front end and back end in the same repository. You fetch it, you run make install, and then you can make start back end, make start front end, and have the thing running locally. Go log in, add a live map block, and it should work unless I'm forgetting some detail. Yeah, that's my presentation, but I'd be happy to take any questions.
So anyone have a question? No? So that's
Feel free to find me in the hall if you want to talk. Thank you.
Okay, guys, I'd like to give a short notice. In the end of the day, we will have some short lightning talks that will be held in the Jam Ferry Auditorium. They're short talks, about 5 minutes in length. If you want to sign up, please use the board in the hall. Thank you. The next talk will be 2:40.